Hi, good day everyone. My name is Monica Bae and I will be your mathematics teacher for today. But before we start, please prepare a pair of paper and pen so that you can take down notes while listening, and you will use this later in answering some of the exercises. Okay, so please bend your ears and eyes and listen carefully. So our topic for today will be functions and relations. And our objectives are distinguish functions from relations, familiarize on different ways of representing function, and apply functions in real-life situations. So before we start, I just want to give you some of the famous relationship or couple that we know in our time. So for example, Julia Barreto and Joshua Garcia. They make a good tandem, right? The next one is Barbie Forteza and Jack Roberto. And also Bea Alonzo and Gerald Anderson. So they are just some of the couples that we know that are working properly before. Not until everything is good, not until Julia Barreto has a spread rumor that she is having an affair with Gerald Anderson. So starting from that, little by little, everything went blurred. Everything is starting, their relationship is starting to lose their function. So the concept of this one is highly similar to the concept of our relations and functions in mathematics. Why? So let's find out. So by definition, relation is any set of ordered pairs. So relation is set of ordered pairs, meaning we have pair of numbers. However, they come in sets. So the set of the first coordinate is called the domain of the relation, or the abscissa, or the x. And then the set of all second coordinates is called the range. So some terms is y or the ordinate. Okay. So if there is x, there is y. If there is abscissa, there is ordinate. If there is domain, if there is range. Just like if there is Julia, there is Joshua Garcia. If there is Barbie Forteza, there is Jack Roberto. Everything comes in pairs. Okay. Next. So let me give you an example of relations. So a set of 1, 3, 1, 2, 0, 8, and 9, 3. So the first one ordered pair is 1, 3. So this is an ordered pair. So the domains are, I colored red all of the domains, which is 1, 0, and 9. So as you can see, 1 appears twice. So we don't have to put it or write it twice in our domain. 1 is enough. It's just the same. And then the blue one is that we call the range. So these are the set of 3, 2, and 8. So since it is an ordered pair, and also they have the domain and they have the range, therefore we can consider this as a relation. Okay? Next example. A set of 1, 4, 2, 5, and 3, 6. So the color reds, or the first set of the coordinate, those are the domain, which is the set of 1, 2, 3. And then the blue one, or the second set of the coordinate, that is the range, which is the set of 4, 5, 6. Since it is an ordered pair, and this is also, it has also an domain, also has a range, therefore that is a relation. Okay, example 3. How about this one? A set of 1, 3, 5, 7. Do we consider this also a range, rather relation? Let's see. Since it does not have an ordered pair, it does not also have a domain, and this does not also have range. Therefore, this one is not considered as relation because this is just a set of numbers. This is not a set of ordered pairs. That's why we do not consider this a relation. Are we clear? Okay, so example number 4. So a set of set to 3 and a set to 5. Is this a relation or not? Let's see. Is that an ordered pair? None. This is not an ordered pair. This is just a set of sets. It does happen that we have 2 elements in every set, but it does not matter that those are the domain and range. Those are just the elements. Okay? So, since it does not have an ordered pair, it does not have domain, and this does not also have the range. Therefore, we cannot consider this as a relation. Okay? So, do I make myself clear about relation? Just remember that a relation is a set of ordered pairs. There is always x and y, domain and range, abscissa and ordinate. Always come in pair. Okay? Okay, so let's go with function. So when we say function, it is a relation, meaning all of function is a relation. Okay? All things that has function has relation, let's say. So it is a relation in which for every first element x, there corresponds a unique second element y, meaning the usage or the value of x cannot be used twice or more in the value of y. If there is one x, there is only one y. If there is Julia, there should be only Joshua, not Julia and Joshua, not Joshua and Gerald. That's not possible. Okay, so it's not a function if that happens. So function is denoted by y is equal to f of x, which reads f of x, or the value of the function at x. So example of function. So the set of 1, 6, 2, 7, 3, 8, and 4, 9. So if you are going to look at the domain or the x, the set of 1, 2, 3, 4, domain has not been repeated. So that is considered as function. Next one, set of -1, 0, 3, 0, 5, 0. So the domains are set of -1, 3, and 5. So no domains has been repeated, therefore that is a function. Next one, set of 5, 4, 2, 7. So the domains are 5, 2, therefore this is also a function. And then the last one is set of 0, 4, -3, 1/2, 5, 0. So the set of domains are 0, -3, and 5. So no domains has been repeated, therefore, therefore this is also considered as a function. Okay, so we can represent functions in 5 different ways. So the first one is ordered pair. So this is the most common use on how to represent a function. So an example is a set of 1, 6, 2, 7, 3, 8, 4, 9, and 5, 10. Wherein you can see the braces and the parentheses. Those are the ordered pairs. So the next one is the tabular form. From the root word table, so the domain and range is in the table form, wherein x is 1, 2, 3, 4, 5, and y is 6, 7, 8, 9, and 10. So in this case, you can easily see if the domain has been repeated or not. Next one is set notation or open sentence. So for example, this one, F is the set of ordered pairs x, y such that y is equal to x plus 5 and x is equal to 1, 2, 3, 4, 5. In open sentence, that is y is equal to x plus 5 such that x is equal to 1, 2, 3, 4, and 5. So that is an example of set notation and open sentence. So the fourth one is arrow diagram or mapping. So arrow diagram wherein you can see arrows. It directly state that 1 is for 6 alone, 2 is for 7 alone, 3 is for 8 alone, 4 is for 9, and 5 is for 10. That's for arrow diagram. You can see arrows, of course. However, in arrow diagram, there is 3 types, where is one-to-one correspondence, many-to-one correspondence, and one-to-many correspondence. So let's see the difference between the 3. So when we say one-to-one correspondence, so you can see that in every x there is y. That's why it was called one-to-one. If there is 1, there is 6. 1 is for 6 alone, 2 is for 7 alone, 3 is for 8 alone, and so on and so on. However, when we say many-to-one correspondence, if you can see, the domain, the range rather, has been used twice or more in the value of the x or the domain. That is why it is called many-to-one. For example, 1, 7, 2, 7, 3, 9, 4, 9, 5, 9. So the value of y has been used many times. And the next one is one-to-many correspondence. So in this case, the domain has been used many times. So this makes the set 1, 6, 1, 7, 1, 8, 5, 9, and 5, 10. If you observe our correspondence between one-to-one correspondence, many-to-one correspondence, and one-to-many correspondence, 2 of them are functions and 1 is not, which is one-to-one correspondence and many-to-one correspondence is considered as function. However, one-to-many correspondence is considered not function, but only a relation, because the usage of x has been used many times. Okay? Don't forget that. And then the 5th way of representing a function is in the graphical form. So this is an example of graphical form wherein f of x is equal to x. And then this is the table of values. So those are the 5 ways in representing a function. Number 1, ordered pair. 2, tabular form. 3, set notation or open space. 4, arrow diagram or mapping. Under that is one-to-one correspondence, many-to-one correspondence, and one-to-many correspondence. And then the 5th one is graphical form. So take note that all functions is relation. Okay? But not all relation is function. Or in easy way, all functions are as relations, but not all relations has functions. Okay, so let us practice. The direction is determine which of the following relations are functions, and then state the domain and range of each relation. So you are going to state if that is a function or relation. However, all of these are relation. However, there is a relations that are not functions. Okay, so number 1, a set of 4, 10, 2, 10, a set of 4, 10, 2, 8, 4, negative 7. So is this a function or relation? Write it on your paper. Let's see. So that is not function. Why? Because if you look at the domain, the domains are the set of 4, 2, and 4 again. Therefore, 4 has been repeated. Therefore, this is not function. Number 2. A set of 1, 4, negative 7, 3, negative 1, 2, 8, 4. Is this a function or not? If that is a function, or write the domain and range in your papers. So that is also a function. So what are the domains? 1, negative 7, negative 1, and 8. And then the range are the set of 4, 3, 2, and 8. Okay? Number 3. Set of 6, negative 1, negative 7, 5, 8, negative 1, negative 2, 0. Is it a function or relation? That is a function. So the domains are 6, negative 7, 8, negative 2. And then the range are negative 1, 5, negative 1, 0. Okay, so if you can see, the negative 1 in the range has been repeated, but it does not matter. X cannot be repeated, but Y can be. Okay, so let's just say in that way. Yes, it's unfair that the X cannot be repeated, but Y can be repeated. That is the rule. Number 4. A set of 0, 0, 1, 1, 2, 2. So is this a function or not? Is this a function or relation? So this is a function wherein the domains are 0, 1, 2. And then the range are 0, 1, 2 also. 5. Set of 6, 9, 4, 8, 4, negative 3. Is this a function or not? This is not function because in the domain, which is the 4, has been repeated. Therefore, this is not function but relation. Okay. So sit work, this is your time. And our directions are read and answer each questions carefully, and then write and show your solution in a clean sheet of paper if there is a necessary solution. And take a photo of your answers and solution, then post it on your Facebook account. Don't forget to use hashtag Matinix, and kindly tag my Facebook account Monica Gutierrez Bae so that I can able to see it. And then the deadline will be until 12 midnight of the present 12 midnight of the day. Okay, so we are counting on it. So this is the questions. You can take screenshots of this. So graph the relation represented by each of the following and tell whether the relation is a function or not. So that's all for today. So a function and relation, the difference between the two is a relation is a set of ordered pairs wherein if there is x, there is y. If there is abscissa, there is ordinate. If there is domain, there is range. However, when we say function, there is only the usage of x, or the value of the domain should not be repeated or used many times. Of course, there should be, for every x, there is y. Okay? So, that's all for today. Hope you learned something. Goodbye.